Well, hello friends. Today we are going to try to make something go fast because yesterday I added the 4chan catalog viewer thingy, and one thing I noticed is that the JSON parsing is just taking up a lot of time, so we're going to try to do something about that. Now, the way that we're going to approach this is the way that you really should approach performance work, which is to first measure and then work based on what you measure. So first thing we'll do is grab one of those 4chan catalog JSONs. What was it? Something like this. Yeah, I have it right here in the history. So we'll just grab this and we'll go in the act tests directory here and we'll wget that. Maybe we'll call that 4chan catalog. And then let's see, test JSON. So we have a JSON auto test or unit test here, but we're gonna need a little bit more fun stuff. Let's see, so how do we do this? I guess we do a benchmark case. And we'll say load 4chan catalog. Okay, and then it's going to be called 4chan catalog JSON. And then it's all about just loading the thing. So let's just start with this, and we'll see if we can make this work. Test JSON, is it -- bench? Yeah. And then maybe we'll also, let's say that we do this a couple of times. Auto string is for 0 to, I don't know, 10? I guess we can try 100, because why not? Okay. It's taking a bit long actually, but how long is that? 1.8 seconds. So, okay, so let's try to see if we can cut that in half somehow. So the first thing we'll do is we'll just divide by 10, and then we're gonna run call grind on the thing so that we can get some profiling data. Now, I haven't been doing performance work on Linux for like almost 10 years, so I'm a little bit out of touch here, but I do remember call grind and kcache grind, so I think I have those locally here, so we're gonna just do it the way I did it in the past, and then we'll see. We'll see what comes out of it. Okay, so we have a profile here, and we can open it up in kcache grind, and let's just see what's the outermost action. So JSON parser parse, that makes sense. Parse array, makes sense that that's next because it's an array, and then we parse the different entries, and then we end up in a few different places, blah 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 blah. So let's look at what's like suspiciously heavy here. So copy from, that doesn't sound good. We shouldn't be copying values during a parse. We should only be creating values. So why are we copying them? Let's look at this guy and see who calls him. It's this guy. And the JSON value copy constructor is invoked by parse array. Okay, so let's go look at that. Parse array. So this is invoking the JSON value copy constructor. I guess because of the return type. Well, it always returns a JSON array, so we can just make it do that. Same thing up here for JSON object, actually. But I'm probably just moving the problem one step out. But we can test that right away. We'll just make a new profile. I'm pretty sure that, yeah, it's the same number of instructions basically. So I'm pretty sure that I just moved the problem. So let's see. Copy from still very, very heavy. But who's calling it? JSON value, copy constructor. Still called by parser array. Yeah, okay. So let's have a look at this. So who calls parser array? It's here, JSON value parse. So we parse out a, if it starts with a open bracket, then we parse an array, and then we return that as a JSON value. So what happens when you call a JSON value with a R value reference to a JSON array? Because a JSON array doesn't inherit from anything, so it's just its own thing. I'm guessing that we choose this guy right here, so that's not perfect. Let's see if we can add some move constructors for these two guys. And I guess we're also going to need JSON array. We can just delete these for now, because I don't have to implement them. I'll just say fix me, implement these. Okay, and then we have these two guys right here, but we're gonna make move variants of them. So if you do this, then we move the object. And assign JSON array. Oh shit. Right, so there we go. Okay. Test JSON. What was the number we had before? 1800? Probably not much faster yet. Yeah, still the same. Okay, well, let's get another profile. And let's actually rebuild in between. Okay, so we're still heavy on copy from. Where did it go? Copy from. It says JSON value, copy from JSON value. This guy, and then here it is. Why are we copying so many values? Array, append, whatever we parse. Oh, wait, hold on. Array, append. Append. Where's append? Aha. We're gonna need a, definitely gonna need one of these. Moving append. That should help. Okay, test JSON. like the reason that I keep changing this is because profiling it with 100 iterations is just going to be very, very slow. Still no change. Oh, keep going. I'm used to doing this on the Mac with the instruments tool. So I'm like feel very disoriented in KCachegrind, but we'll figure this out as we go. So we're still doing a whole bunch of copying. Why? I don't understand. Okay, well, let's just look for it. So we call parse array, JSON value, and who calls parse. We parse here, and we append what we parse here. Okay. Let's see what else we can look at then. I almost feel like this thing is lying to me, but maybe it's not. Why is parse array invoking the JSON value copy constructor? I don't get it. Append what we parse, which is a JSON value. And he's copying a whole bunch of shit below there, but why? Wait, are we like... I just want to verify that this thing is actually rebuilding. Bench. Okay, so we may have not been rebuilding. Let's get a new profile. It seems like we may have successfully gotten rid of those copy constructors. Oh, but we need 10 iterations. Yeah, because I just couldn't figure out where they went, and seems like maybe we didn't do a full enough rebuild. Yeah, we have significantly fewer cycles, so that's a good sign. Oops. Let's see what else we can find. Well, copy from is still here, but it's called less now. We'll figure that out too. So parse is calling moving the JSON array into a JSON value. That's what we want. But why is that slow? It's still invoking JSON value copy constructors. So you move a value, you move an array into a value. That's this one. So you're calling this. I guess we should spell out the. We'll just spell these out. Their values. Move other values, and also we'll do the if this is not other than m values is move other, no, not move. Like that, and then a very similar move assignment. Zip, zip, zip. Okay. And I guess we can do the same for JSON object, because the object is like an array, except he has a map of string to value internally instead of an array of things. So we'll just fix this up right quick, and then it's called m members instead of m values. Okay. Make clean. Test. Let's do the 100 thing, see how this works. Test JSON bench. Come on. Let's see it. Ooh, look at that number. Holy shit. 696. That's pretty good. Okay, so we are definitely well below half. That's good. So let's see what else we can find. Oh fuck, I forgot to build. Although forgetting to build is becoming more and more okay, like the faster it gets, because getting a profile will be faster and faster anyway. Okay, so what are we doing now? Start the thing, blah, blah, blah. I don't see any copying. That's very good. So inclusive is kind of interesting here, right? Because it just, it's the function plus everything that he calls. So it's, I like to sort by that, but you can also sort by self, where you see like time spent in a function, not in one of its callees, but in the function itself. So you can see that consume quoted string is the heaviest in terms of like time spent in itself. I guess we can look at that right quick just to see if there's something obvious that stands out here. Just iterating, peeking at the input stream, and then consuming characters one by one, and then appending them to a vector as we build up the quoted string. There's definitely ways to do that faster, but that's like, I'm looking for more high-level stuff here, so I don't want to get into the low-level details right now. So let's look at inclusive instead. So let's see. I mean, it's kind of heavy on the inclusive side as well, so who does he call? Let's look at the call graph. He calls string creation. Oh, that makes sense. And allocation is the bulk of that, right? Because he's just creating a whole bunch of strings. What about parse object? Okay, and who calls clear? Parse object calls JSON value clear. I wonder why that is. Let's see. Value. Maybe it's this one right here. It's being cleared, so we create a value and then we just pass it directly here, and then, because I think JSON value destructor would call clear. Yeah, and clear is out of line, which is a bit unfortunate. But I'm not sure if we can really avoid that. Is it really that heavy though? I think probably it's not so heavy in this case. It's just heavy because it's being called from elsewhere. It's being called from, yeah, right. So parse object is like 1% of the clearing, and then this guy is like 11%. Or not of the clearing, but like of the total. So this guy is the heavy reason that we are doing JSON value clear, and it's because we're doing the test 10 times. So like for each iteration, we have to actually destroy this JSON that we parsed. Parse number, what do we have in there? Extract while. Extract while. So extract while makes a copy. Maybe that could be avoided. Because when we're parsing a number, we don't care about getting the number. We don't want to keep the number string, so we would be fine if we just got a view with the number. So we could have a version of this, or who else calls this? Extract while. Parse number, it's the only thing that calls this. Well, let's just make it give us a view instead then. But how do we do this? So maybe an easier thing to do would be to just let's see, number string, number characters, and we'll say extract while will return a vector of char. Maybe this is the easiest way to do this. Just return a vector char. This means that we put the first kilobyte on the stack. We don't bother making any heap allocations. So in the typical case, we won't get any heap allocations. Although this, since we're only using it for number parsing, this is a really extreme number. So let's say 128 instead. Okay, then here we'll say number buffer view number buffer. Can we do this? Data number buffer size. Number. I mean, we can still call it number string, but it will just be a number string view. Okay, so now we make ourselves a little string view. There is no string view to int. What? Okay. Well, that's unfortunate. Should I just be a lazy bastard and copy paste it? I think I will. This is slightly disgusting, but I'm gonna do it anyway. To int. Why am I this way? We shouldn't be keeping this. But we'll see how much this gives us. Fix me. This is definitely a fix me. Where do they go? To int. Fix me. These should be shared between string and string view somehow. To int. We'll add the same comment here. Okay, and then this JSON. We'll go back to 100 and make. $645, so it's like not really significantly different. Dang it. Let's see what we can get from it though. Look in the profile. Oh shit, no, that's too big of a profile. That's not what I wanted. Test JSON. 261. What was the previous one? Do we have? Blah, 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 blah. 273. So we're shaving some off, but it's not that much. Okay. Where did parse number go? There he is. Parse number calls toUint. I mean, that's kind of cute that it doesn't create any strings, right? Of course, consume quoted string is gonna have to create strings. What do we do here? Compute hash. These are really small. Consume quoted string is very heavy though. Consume quoted string. Is there something obvious here that stands out? Can we look at the machine code? No, we can't. This UI is such a mess. But is it actually telling me something interesting? This is, I guess these numbers are like time or samples on that particular line. So here's somewhat heavy. And the return. Consume quoted. So who calls this? Name. So parse string. Right. So I'm thinking like one thing we could do is we could have a string table where we reuse strings that we've already seen. Because I think often in JSON, you end up with the same keys over and over, right? So that's one way that we could make this go faster. Let's do some commits though. Let's do these first, stack string and string view. Cached. Right, so this is just add string view to int. A shameless copy paste of string to int. We should find a way, some way to share this code between string and string view instead of two duplicate copies like this. And then see a whole bunch of stuff. So let's do JSON array, because I think these are just adding constructors and assignment operators, right? Yeah, so JSON, let's say JSON, add copy and move copy and move constructors object. This avoids copying JSON values during parsing. This helps avoid. Okay, what else did we have? Just that little extract while thing. And oh shit, we gotta do the JSON value stuff as well. JSON value. Right, so move constructors for JSON value when you're moving an array or object into them. Okay, so JSON object, move constructors for object. This also helps avoid JSON value copying during parse. And what else? Just these little guys here in the parser. So returning an array instead of a. Okay, so let's just say JSON parser. JSON parser, some minor optimizations. Return the appropriate narrow object type from parse array and parse object. Specific. And blah blah blah, and create a throwaway string in extract while, and use a string view. Parse number to avoid string. Okay, I think that's pretty good. Some dots, because I like dots. Okay, and then so should I do the string deduplication tag? I guess we can do that. So let's see. How do we find that? Because we don't have a string when we start out, we only have a buffer of characters. So if we make a hash table of strings, then find, we can provide our own finder. Okay, that's cool, because that means that we can hash the thing ourselves. We don't need a string to look into a table of strings. Okay, so let's see. Table string, call it scene strings, something like that. Okay, and then consume quoted string. Before we create this guy right here, we'll do something like unsigned hash is string hash, just auto hash, buffer data and buffer size, and then we'll call mscene strings. Okay. Find hash. And, oh Jesus, how the hell do we use the finder? I don't remember how this works. This is to compare entries, right? Okay, so it's just an equality helper. So we'll have to do that, and we'll say entry return strcomp, or I guess, hold on, let's be a bit smarter here. If entry dot length is not buffer size, buffer is empty, return string empty, return false, and otherwise return strcomp or memcomp entry characters and my characters, buffer data, buffer size. If it is not scene strings.end, reused a string. That's cool. It dot, no? How do I get the string? Like that, okay. Return IT. Otherwise, we will have to add it. So we'll say scene strings dot set, or auto string is okay. I hope I got that right. Look at that, it's reusing all these strings. Okay, so let's not print that, and let's profile it and see what we get. Well, that's slower. Wonder why it's slower. I guess we can find out. Probably the hash table is not as efficient as I would like it to be. And, oh, I forgot to change the iteration count. I forgot to rebuild. Or did I? I'm getting a little confused here. 305, yeah, so we have more events now in the call-around log. Let's see where those new ones are. So that would be in consume quoted string, then call emap, all callees. We're just doing all of this now instead, which is hash table set. Wait, no, not hash table set. Wait, is that the heavy part? It's hash table set? So these are very long names. Can we get them like that? Hash table set, that's the heavy part. I guess I would have thought that the find would be the heavy part. Set is heavy because we have to rehash. That makes sense. So maybe this was not the best idea. Seems like it's more expensive to do the hash table than to do this. Okay, so anyways, let's just scrap that idea. And it's not parser. Because like if you come up with some idea and it doesn't work out, then you gotta let it go. You don't have to push it. String copy of an empty string. It's already handled here, yeah. So to check out, I'm just gonna, I guess we should add this little test here. Should I anonymize this thing? I mean, it's already anonymous. It's full of gunk. I was just thinking, like, I hope it doesn't have anything horrible in it. I'm just not gonna look. You know, we'll just add it. Test JSON. Test JSON. Because I think that's a pretty good test, and in the end, like, since we run tests on every build, and I don't wanna delay running the build by that much, but we can see here that we got it down to about 600 milliseconds or 650 from, what was it when we started, 1800, something like that. So we're down to a third, which is pretty decent. And then we are officially gonna give up on the consume quoted string right now. Git commit ack or add a benchmark for parsing 4chan catalog JSON. I was able to get parsing time down to about 1/3 of the original time by using call grind, cache grind. There's definitely more improvements that can be made here, but I'm gonna be happy with this for now. Cool. Okay, so I guess we should see that it works in context. So we'll do a full build, then we will actually use the parser to hopefully load the 4chan catalog live a little bit faster than before. Of course, we won't have any comparison, but we know that the parsing is faster because we've measured it. It is party time. Excellent. I think I watched Wayne's World like 100 times when I was a teenager. So today is your day, Wayne and Garth. For being the wallpaper, I mean. Come on, compiler. Wow, this feels like unusually slow today. At some point, maybe I should consider getting a new computer. This is not it's not a fast computer by any means. It's like one of those little mini PCs that you keep on your desk. I just looked for one that looked silent, which it is. But it is a bit slow sometimes. Anyways, come on. Why is it so crazy slow? Just recording. Nothing crazy. All right. Did I put some weird flag on or something? No? Well, now I'm sort of worried that it's going to be hard to appreciate any performance improvements because everything feels so slow. But yeah, it certainly loaded. I mean, probably faster than it would have before. I couldn't tell. But it's still working. That's the important part right now. It's really cool. So, was this the best operating system ever made? Probably not. But I'm gonna try to make the best operating system now. It's gonna take some time, but we'll get there. Anyways, so I think we're gonna cut it off here. But if you made it this far, then I thank you for watching and for hanging out with me. A little bit unusual video today where we do some performance work and profiling driven hacking instead of just the usual building stuff. But it was kind of fun. Got some good stuff done. So I hope you saw something interesting. And if you know about some cool performance analysis tools, some profiling tools and stuff like that for Linux, then please do tell me, because I have very outdated information. I haven't done this type of stuff on Linux for many, many years, so I appreciate any suggestions. Other than that, I'm just going to say thank you for hanging out, for being here, and what else? And I'll see you next time. Bye.